Hi, welcome back to Moose and Chemistry. Redox, oxidation reduction in acidic solution, problem number 3. This is going to be a redox reaction in acidic solution. This one's going to be a lot tougher than some of the others we've ever done. And so what we're going to do is we're going to actually break these into what we call half reactions. So let's go ahead and do that. PO2 yields PO4. You will notice that you have 4 oxygens on this side of the reaction, right? So that means we have 2 over here, so we have to add 2 oxygens. So we're going to go 2H2O. And that's going to give us our 4 oxygens, right? So that's going to work out okay. Now, let's look at the other half reaction here. So we got Cr2O7 2 negative yields two Cr3 plus. Why do we put a 2 there? Because we have a 2 right here. Alright, so let's go ahead and let's carry on. Now the next thing we're going to do is we're going to have to change a few things here. Look at the first reaction, all right? PO2 plus H2O yields PO4. So let's make that look a little bit better. That's okay if this video goes a lot longer than normal because this one is definitely a very hard problem. So we go PO2 plus 2H2O yields PO4. Okay, so let's go ahead and clean that up a bit because that looks kind of a weird looking O there. So again, like I said, we're just going to take our time and we're going to make our 4 look a little bit better. There you go. So now we have 4 hydrogens on the left side. See that? 2 times 2 is 4. So we're going to have 4 hydrogens on the right side. So let's go ahead and make 4 hydrogens on the right side. So I'm going to add 4 hydrogens to right here. Okay, so let's look at the one down here. We have 7 oxygens here, right? And no oxygens on the right side, right? So we need to balance that. So let's go ahead and do that. So let's go ahead and add 7 oxygens onto this side right here. All right, now look, that gives us a total of 14 hydrogens there, right? So we have to put 14 hydrogens on this side. So far, so good. Okay, things are starting to look a lot better. Okay, now, let's look at the next thing here. So we have 4 hydrogens on the left side and 4 hydrogens on the right side. Well, we know that PO2 has a -3 charge because we have H3 right here. And we also know that PO4 has a -3 charge also because of the H3 here. Okay, so that means that this guy right here must be, to get this to be a -3 charge, right? Let's see here, 2 times -2 is -4. Okay, and this is going to be 2 times -8. So this is going to give me a -4 here overall. So 2 times negative, 2 is a -4, right? And then 2 times -2 times 4 is a -8, right? So we got to get rid of, we need to make this, see that's a -4. This guy right here is a -4 right there. And this guy here makes a -8. So in order to bring this -8 down, we have to add 4 electrons to this side. That'll drop that -8 down to a -4 like the other side. So let's go ahead and clean this up. So we've done that now. And again, you might have to watch this a couple of times to get this down. All right, so let's go ahead and clean all this up. Now we have our -4 electrons here. Now let's look at the one down below, okay? We have 2 times 3, right? So that gives me 6 electrons. To balance the other side, I have to add 6 electrons to the left side here. So let's clean this up a bit. Let's go get the eraser here. And let's erase. Oh, here we go. And now we're going to add 6 electrons to the left side. And again, I know this is difficult, but just kind of follow it along. So this is going to become Cr2O7 2- plus 14 electrons. I mean, not 14 electrons, 14 hydrogens. See, all this stuff is starting to blend together. It's going to get a little bit, starting to get a little bit more difficult. 14 hydrogens plus 6 electrons. Now notice that you have 6 electrons here and 4 electrons here. What's common between 6 and 4? That's simple. That's 12, right? So that means we have to multiply this side by 3, right? This top equation by 3 and this bottom equation by 2. So what's that going to give us? Well, we're also going to put our hydrogens back in now. So this is going to give me 3H3PO2 plus 6H2O, right? Follow me so far? Okay. Which will also then give me 3H3PO4. Make that 4 a little bit better. That way we can also take a breather for a moment because this is a lot to digest. Okay. And like I said, this is a really hard problem. Plus 12 hydrogens, because 4 times 3 is 12. Okay. Plus 12 electrons. On the bottom one, we're going to multiply everything by 2. So this is going to give me 2Cr2O7 2-, right? Make that 2 a little bit better. Plus it gives us a chance to think about it for a moment here. Because this is quite an impressive problem. So 2 times 6 will give us 12 waters, 12 H2O. Okay. Whoops. I blew that one there, didn't I? I got a little confused, but that's okay because there's a lot of writing on the board here. So, not a problem. 2 times 14 is 28 hydrogens. Oops. Sorry about that. Plus 12 electrons yields 4Cr3 plus 14 H2O. Now, we're almost there. What we need to do now is to combine these 2 equations back together to get our final equation. So we're going to get a little bit of help here, and we're going to start eliminating things. Okay, so watch this. I have 12 electrons on this side, and I have 12 electrons on that side. So I can get rid of those electrons, okay? I have 12 hydrogens on this side, right? So what I'm going to do is I'm going to reduce that, right? I'll take that 12 hydrogens on this side and take that away from here to get 16 hydrogens now. See that? 16 hydrogens there. Okay, look at our waters. We're going to get rid of the water, get 6 waters here. So we're going to get rid of the 14 waters, and that's going to give me 8 waters there. So now, let's take a break for a minute. Now, what we want to do now is combine what is left over. So we're going to add the left side together, and then we're going to add the right side together, and that's going to give us our final product. So now let's go ahead and do that. And again, like I said, this is quite an undertaking. This is not an easy problem. So this is going to be 3H3PO2. And we're going to add that in there, right? Plus 2Cr2 O7 2 minus, okay, plus 16 hydrogens yields 3H3PO4 plus 4Cr3 plus 8H2O. Now, so we need to make this look a little bit cleaner, so I'm going to rewrite it. So the final answer and the best way it should look like this. 16H plus 3H3 PO2 plus 2Cr2 O7 minus 2 yields 3H3 PO4 plus 4Cr3 plus 8H2O. And that's our final answer. This was quite an undertaking. So there's another way to do it, but you can be moving the electrons around a different way. But actually, in this case, this is the best way to do it. And yes, it is a tremendous amount of work. If you like this video, give us a like and consider subscribing so we can grow this channel. You guys be snarly, and we'll see you back here at Musin Chemistry!